Hello, I'm Joshua Pugsley.
I am Vitaly Mazur.
I'm Minglen Song.
And I'm Jonathan.
And together, we're Capstone Group 23, Modular Prosthetic Devices.
Project idea. Create an open source platform from which amputees and other individuals can use our EMG work and platform design to create their own kinds of interchangeable prosthetic devices, enabling both mechanical outputs such as tools and digital outputs through the use of EMG signal interpretation. Our examples of this include the mounting platform designed to attach interchangeable devices to an amputee's appendage, a prototype drill device, and a digital input to a basic game, all to be controlled with muscle group signals.
Let's start with an overview of the modeling of the platform. The main idea was to have a design contoured to the human arm that had a twist and lock mechanism to allow for attachments on top. Printing of the model parts was next, and this opened us up to many obstacles. The main problem was one of delamination, causing the legs to snap off continuously. This was solved by adding more support to the model, changing the infill of the 3D printer, and varying the model orientation.
The motivation for the filter circuit is fairly straightforward. The signal that you get directly from your arm using EMG electrodes is both noisy and small. To compensate for this, we have a circuit divided up into 4 steps: acquisition, amplification, rectification, and low-pass filtering. We knew we both wanted a circuit that we could play with easily, as well as one that could fit into an enclosure. To this end, we had one group member build and debug on a breadboard, while another soldered a polished version of the circuit in parallel. Here you can see our efforts and iterations in chronological order. We actually had a lot of trouble getting our amplifier working consistently. Because the filters are powered with an 18-volt differential, minor errors during construction were enough to destroy components. We actually had to go through 4 sets of chips to get where we are now. While this was initially discouraging, it reinforces our hypothesis that the biggest barrier to entry to prosthetic design is the initial signal processing stage.
Now the digital component. The digital attachment that we completed as a proof of concept involved an Arduino-based run and jump game. The EMG signals obtained through a filter and amplification circuit designed by our group was transmitted to the analog pin of the Arduino microcontroller and then interpreted as a jump function within the code. The biggest challenge we encountered with this milestone was the interpretation of the analog signal within the threshold of a digital output. Now mechanical. As a proof of concept of the mechanical component, we have designed a drill attachment operated with the EMG's inputs. A low-torque screwdriver, drill motor, and a gearbox were chosen to minimize the strain on the 3D printed components of the attachment. As a cost-saving alternative to our initial design, we eliminated the need for the microcontroller by constructing a 4BGT circuit working as a four-way switch collecting inputs from 2 distinct EMG signals, allowing for the rotation of the drill assembly in both clockwise and counterclockwise directions.
Putting all the components together, we are able to create a device that can mount onto an arm, allowing amputees to control their attachments with their own muscular signals. This includes a drill that allows for both clockwise and counterclockwise rotation, and a digital game that can also be played. But the most important aspect is the modularity of the system. Any user should easily be able to create their own attachment for whatever needs they see fit.
In conclusion, we feel we were able to successfully complete our goal of creating a mounting system for modular prosthetic devices and take EMG signals from muscle groups and turn them into useful actions that have the potential to benefit amputees around the world. Our examples are just scratching the surface of what's possible for a system like this, and we can't wait to see what creative ideas people around the world can do with this technology. Thanks for watching!